Okay, Waka, today we're looking at 10.1, defining and evaluating a logarithmic function assignment tutorial. Question 1 of 16. Complete the input-output for f of x equals log base 2 of x, and then graph f of x equals log base 2 of x. Step 1. Complete the input-output for f of x equals log base 2 of x. Okay, so let's go ahead and do that now. So what I'm going to do is I'm going to go to Google, and I'm going to type in Desmos graph and table. All right, I'm going to go to function tables. Move this out of the way. I'm going to delete the table values, keeping the table, delete this, and then I'm going to go here. I'm going to go to functions, miscellaneous. We want that log, and I'm going to put log base 2 of x. Okay. So now I'm going to put the values in 0.25, 0.50, 1, 2, 4, 8. All right, so my values are -2, -1, 0, 1, 2, 3. All right, so there's the table completed. All right, now let's take a look at step 2. Graph f of x equals log base 2 of x. All right, so first thing you'll see here is that we have a vertical asymptote at x equals 0. So let's go ahead and graph that first. Okay, now let's go ahead and graph our point. So we have 0.25, -2, and you just want to approximate that point. 0.5, -1, again, we're just approximating that point. 1, 0, 2, 1, 4, 2, and 8, 3. All right, so there's our graph. All right, go ahead and finish up your graph. All right, now your graph's finished. Let's take a look at the next question. Question 2 of 16. Use a graph of f of x equals log base 2 of x to complete the following. Step 1. The domain of f of x is x such that x is greater than 0. Step 2. The range of f of x is y such that -infinity is less than y less than infinity. Step 3. The end behavior of f of x is as x approaches infinity, f of x approaches infinity. As x approaches 0, f of x approaches -infinity. Okay, step 4. The graph's only x-intercept is at x equals 1. Step 5. The graph has no y-intercept. Step 6. The graph has the y-axis as an asymptote. Step 7. The function has negative values on the interval 0 to 1, and the function has positive values on the interval 1 to infinity. Step 8. The function is increasing throughout its domain. The function never decreases. All right. Question 3 of 16. Consider the exponential function f of x equals 2. Step 1. The domain of f of x is x such that -infinity is less than x less than infinity. Step 2. The range of f of x is y such that y is greater than 0. Step 3. The exponential function is 1 to 1, so no restrictions on its domain are needed in order for its inverse to be a function. Step 4. Find the inverse of f of x equals 2 to the x. Okay, the first step is to change f of x to y, and then you're going to switch x and y. So x equals 2 to the y. Okay, now we need to take log base 2 of both sides. And the reason we do that is because log base 2 of 2 cancels, and you're left with y equals. So y equals log base 2 of x. Since it's the inverse, y is equal to f inverse of x. All right, step 5. The domain of f inverse of x is x such that x is greater than 0. Step 6. The range of f inverse of x is y such that -infinity is less than x. And actually, that should be range is always y, so that should be less than y, less than infinity. All right, go ahead and finish up question 3. All right, question 4 of 16. Enter the exponential equation 4 to the third equals 64 in logarithmic form. The logarithmic form of 4 to the third equals 64 is log base 4 64 equals 3. All right. Question 5 of 16. Enter the exponential equation 1 divided by 20 to the negative 2 equals 400 in logarithmic form. The logarithmic form of 1 divided by 20 to the negative 2 equals 400 is log base 1 divided by 20 of 400 equals negative 2. All right, question 6 of 16. Enter the exponential equation 4 to the m equals n in logarithmic form. The logarithmic form of 4 to the m equals n is log base 4 of n equals m. All right, question 7 of 16. Enter the logarithmic equation log base 4 of 64 equals 3 in exponential form. The exponential form of log base 4 of 64 equals 3 is 4 to the third equals 64. All right, question 8 of 16. Enter the logarithmic equation log base 1 divided by 5 of 1 divided by 625 equals 4 in exponential form. The exponential form of log base 1 divided by 5 of 1 divided by 625 equals 4 is 1 divided by 5 to the fourth power equals 1 divided by 625. All right. Question 9 of 16. Enter the logarithmic equation log base 3 of x equals y in exponential form. The exponential form of log base 3 of x equals y is 3 to the y equals x. All right. Question 10 of 16. If f of x equals log base 4 of x, find f of 1024. So log base 4 of 1024 equals. Now, in this case, using the Inspire is going to work out better than Desmos. So we're going to go to On, New Document, Add Calculator. Now we want to find log. Log's right here. So we do Control log base 4 of 1024 is 5. Okay. Now we're going to do f of 164. So that's log base 4 of 1 divided by 64 equals. So let's put that in our calculator. So I can actually go up, highlight, press enter, change what's in the parentheses. So control divide 1 divided by 64, press enter. So that's negative 3. Okay. Now we have f of square root of 64. So that's log base 4 of the square root of 64 equals. So let's put that in our calculator. So then I'm going to do control log base 4 of control square root of 64 equals 1.5. Okay. All right, go ahead and finish up question 10. All right, question 11 and 16. So if f of x equals log base 4 of x, find f of 16. So that's log base 4 of 16. Okay, so let me come here. I'm going to delete this because that was a previous problem. So control log base 4 of 16 is 2. Okay, so now we're doing f of 1, 4. So that's log base 4 of 1 divided by 4. Okay, so that's control log base 4 of control divide 1 divided by 4 is negative 1. And then this is log base 4 of 4 times the cube root of 4 equals. Okay, so control log base 4 of 4 times control, we want this one. So then that's 3, 4, press enter is 1 point, let's just put 1.3. All right, go ahead and finish up question 11. All right, question 12 of 16. Okay, if f of x equals log base 1/5 of x, find, so that's log base 1/5 of 1 divided by 125 equals. Okay, so I'm going to delete these, control log of control divide 1 divided by 5 of control divide 1 divided by 125, press enter, is 3. Okay, so then this is log of 1/5 of 625. Okay, now what I can do is if I highlight this, press enter, and then I can delete this and put 625, press enter, which is -4. Okay, so then this is log of 1/5 of cube root of 25 equals. Okay, so I'm going to highlight, enter, change this to control up key cube root of 25, which is negative 0.6667. And if I do this, I go to menu, number, approximate fraction, press enter, that's negative 2/3. Okay. All right, go ahead and finish up question 12. All right. Question 13. Use a scientific calculator to find the common logarithm and the natural logarithm of 16. Verify each result by evaluating the approximate exponential expression. If necessary, round your answer to the nearest thousands. Now, when they have log and there's no base, we assume 10. Okay? So I'm going to come over here, delete here. I'm going to do control log 10 of 16. Now it says it wants to the nearest thousands, so that's 10 hundredths thousandths, so 1.204. Okay, now let's do the natural log of, which that key is control E here, and then you're going to put 16, which is 2.772. Okay, go ahead and finish up question 13. All right, question 14. Okay, so control log, and again, if there's no base, we assume it's 10, 0.2, which is negative 6, or negative 0.699, because that 9 raises it 8 to that. And then I'm going to do control E of 0.2 is negative 1.609. Okay, go ahead and finish up number 14. All right. Now, question 15, I recommend using the step-by-step process to help you answer that question. All right, and then question 16, evaluate each expression without using a calculator. Now, the natural log and E cancel each other, so you're left with 2. Okay, the 10 and the log cancel each other, and you're left with 9. Okay, now let's verify those. So control natural log of control, not control, E, sorry, E to the 2, you can see we get 2, and then 10 up key, control log, and again base 10 of 9 equals 9. And then let's just go ahead and while we're here, go ahead and put the last question in. So 4 up key control log base 10. Oh, I'm sorry, log base 2 of 7, which is 49. All right. Go ahead and finish up question 16 and go ahead and finish up your assignment and have a wonderful Wildcat day.